So today we have an interesting geometrical problem. We take a square, now we draw another square such that the diagonal of this new square is the side length of the previous one. Now we draw a line segment joining these two vertices of these two squares. Now we shade this region in green color and this particular region in blue color. So the question over here is to find the value of the fraction area of the green region upon area of the blue region. So this is Anmol, and now let us see the solution. How can we solve this problem? So first of all, we will start the solution by taking the side length of the bigger square as a variable x and the side length of the smaller square as a variable y. Now as per the given data related to the arrangement of this diagram, we can easily find the value of y in terms of x. So look carefully, it was given that the side length of the bigger square is the diagonal for the smaller square. Hence this is the side of the bigger square, it would have a value x. These two sides of the smaller square would have value y. And this angle over there is 90 degree because it is the corner of the smaller square. Now in this particular right angle triangle, by applying the Pythagoras theorem, we can easily get the value of y in terms of x, that is y equals to x upon square root of 2. So here we have got the value of y in terms of x. Now to move further in the solution, we will again use the fact that this side is the diagonal for the smaller square. So in a square, we know that the diagonal bisects the 90 degree as 45, 45. So look at the corner PBQ in the smaller square. Because of this diagonal, these two angles would get bisected and would have a value 45 degree. Now we can see that the complete angle ABC is going to be 90 degree because it is the corner of the bigger square. Some part of that angle is already 45 degree, hence the remaining angle, that is this much, would have a value 45 degree. Okay. Now what I will do is I'll simply take the length of the line segment BM as a variable A and the length of the line segment BN as a variable B. The length of the line segment BQ is the side length of the smaller square, hence it is going to have a value x upon square root of 2. The side length AB is the side of the bigger square, hence it would have a value x. Now we can see that the angle ABC is 90 degree because it is the corner of the bigger square, and the angle PBQ is also 90 degree because it is the corner in the smaller square, hence both of them would have a value 90 degree. Okay, so here we have finished the marking of all the required things in the diagram. Now let us move on to the solution. So first of all, take the area of the triangle MBQ. Now how we are going to get this one? So in the diagram, the triangle MBQ is present over here. Now in this triangle, we can see that the angle MBQ is 90 degree because it is the corner of the smaller square. The height of this triangle we have already taken as a variable A, and the base of this triangle is x upon 2. Hence the area of this triangle would be half the base x upon square root of 2 into the height, that is A. So this thing is ultimately ax upon 2 square root of 2, and this is the area of the triangle MBQ. Now what we required in this required fraction is area of the blue region. So from this complete triangle MBQ, if I subtract the area of this remaining region, what we get is the blue area, simple. So area of the triangle MBQ minus the area of the triangle MBN. Now here we need to get the area of the triangle MBN. But what we can see that in this triangle, we neither have the height and neither this triangle is a right angle triangle. But in this triangle, one of the angle is having a value 45 degree. So remember the formula for area of the triangle, that is, if in a triangle, one of the middle angle is theta and the adjacent side to this angle are x and y, the area of the triangle is half the product of the adjacent sides, so x into y, multiplied with sine of that central angle, so sine of theta. So in this triangle, the adjacent sides are A and B and the angle present between them is 45 degree. So in this formula, we'll replace x equals to A, y equals to b, and theta equals to 45 degree. So the area will come like half times A times b times sine of 45 degree. Now sine 45 has a value 1 upon square root of 2. So this final area would be equals to A into b divided by 2 square root of 2. And this is the area of the triangle MBN. So here in this equation, we'll replace this value. So this is already the area of the triangle MBQ minus the area of the triangle MBN, that is AB upon 2 square root of 2. Now we can see that when we subtract the area of the triangle MBN from the area of the triangle MBQ according to this diagram, the result will be the area of the triangle that is shaded in blue. So AX upon 2 square root of 2 minus AB upon 2 square root of 2 is ultimately the area blue. Okay. Now the same thing we will do in order to get the area green. So here I will take the area of the triangle ABN that is present like this way. In this triangle we can already see that the angle ABC is 90 degree, means the angle B is 90 degree. Hence this triangle is a right angle triangle. So the formula would be simple: half base into height. Base is X and height we have taken as a variable B. So this is the area of the triangle ABN. What we need in this required fraction is the area of the green region. So in order to get the area of this green triangle, I will simply subtract the area of this particular triangle from the triangle ABN. Now the triangle that we have to subtract is the triangle MBN. So previously we have already got the value of the triangle MBN, and that was AB upon 2 square root of 2, and this thing has to be subtracted. So this thing will finally turn out to be XB upon 2 minus AB upon 2 square root of 2, and this thing is the area green. So now here we have the area of the green region and area of the blue region. Now when we simply go ahead and divide these two equations in order to get the value of the required fraction, we can see that on the right hand side the fraction will not divide very nicely. X into B upon 2 minus AB upon 2 square root of 2 divided by AX upon 2 square root of 2 minus AB upon 2 root 2. This thing will not give me a nice result. I mean, in this type of question, the value of this kind of fraction are always perfect real numbers or in terms of some variable that is already given in this problem. But in the problem we were not having any kind of variable already given. This means this fraction need to be a real number. So we can say that when we simply divide these two values of area of blue and area of green, the result is not a nice number. And this is happening because the area of the green triangle is in two terms and area of the blue triangle is also in two terms. So when two terms are present, the cancellation work from the numerator and in the denominator becomes difficult. This means we need to get these areas in single term. And surprisingly, we can easily get these values also as per this diagram. Look carefully for this blue triangle first of all. In the blue triangle, we can see that the adjacent sides are B and X upon square root of 2. And here we have the central angle that is already having the value 45 degree. So by using this particular method, the area of the blue triangle would be equals to half product of the adjacent. So B into X upon square root of 2 into sine of 45 degree, because the central angle is having a value 45. Sine 45 has a value 1 upon square root of 2. So after multiplying these terms, the result would be X into B divided by 4. So here we have got the area of the blue triangle in a single term. Now similarly we can get the area of the green triangle also, because the central angle in green triangle is also 45 degree. The area of the green triangle would be equals to 1 by 2 the product of the adjacent sides, so X into A into sine of 45 degree, that is 1 upon square root of 2. So this thing is A into X upon 2 square root of 2. So here we have got the area of the green triangle in a single term. So now here we have the area of the green region and area of the blue region in single term. So let us go ahead and divide these two equations. So on the left hand side we will get the area green divided by the area blue, and this thing would be equals to AX upon 2 square root of 2 divided by BX upon 4. The X can be factored out, so the result would finally be equals to A upon B multiplied with 2 upon square root of 2. So here we have got the area of the green region upon area of the blue region, that is A into B upon 2 square root of 2. But that is not correct. As I told you before, in the questions where we need to find the value of this kind of fraction, the answer should be real number or in terms of variable that is already given in the problem. But here we have got the value of fraction, alright, but in terms of A and B. Now A and B are the variables that we have kept in the question to make our solution easy. So this will not work. So now to simplify this thing further, means to get a perfect real value for area green upon area blue, I need to get a real value for A upon B. And to get this thing, we can simply compare these two areas for the blue region and the two areas that we have got for the green region. This thing that we got previously is not worthless, it is worthy. So Bx upon 4 is the area of the blue region and this thing also area of the blue region. Therefore, Bx upon 4 can be equals to ax upon 2 square root of 2 minus ab upon 2 square root of 2. Now I will simplify this equation to get the value of x. So the value of x would be ab upon 2 square root of 2 divided by a upon 2 square root of 2 minus b upon 4. This is the value of x that we get by comparing these areas for the blue region. Now we also have two values for area of the green region that you can see over here. So these are the two equations that give us the area of the green region. So we can simply compare their right hand side. So by comparing the right hand side, we will get the value of x that would be equals to ab upon 2 square root of 2 divided by b upon 2 minus a upon 2 square root of 2. When you will simply compare the area of the green region, this is the value of x. So we can simply compare this both. So simply these two things would be equals to each other. Now we can see that ab upon 2 square root of 2, ab upon 2 square root of 2 got cancelled out from the numerator. When we will do the cross multiplication, we will finally get a upon 2 square root of 2 minus b upon 4 equals to this particular thing. Now in this equation, if we simplify the like terms, we will get a upon square root of 2 equals to 3 times b upon 4. Okay. Now over here, I will simply do the cross multiplication. So I will get the value of a upon b equals to 3 square root of 2 divided by 4. Now recall that to get the value of the required fraction, we got an equation, but there was a problem. In the equation, a upon b was present. So for that reason, we were trying to find the value of a upon b in a real number, and here it is. So let us go ahead and replace a upon b with this value in that equation. So the equation is over here. So a upon b is now turned out to be 3 square root of 2 divided by 4. This thing multiplied with 2 upon square root of 2. Square root 2 got cancelled out from the table of 2. This thing goes as 2. So finally, the area of the green region upon the area of the blue region is equals to 3 upon 2. And that's the answer that we were looking for. So this was my way to solve this particular problem. If you have any other method other than this, or else if you have any other question that you think I should try, you can do comment below, and if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description.